Oh yes. The question says a tempered load of mass 200 gram is 160 centimeter long. It balances at its midpoint when 150 gram mass hangs from the narrow end. How far is the center of gravity from the thick end? Now, the first thing we need to understand here is about the tempered load. Now, the tempered load is unlike a straight load with a constant diameter. A tempered load diameter reduces progressively along its length. So what we need to understand here, this problem is about balancing and tackle. By attaching weight to one end of the rod, we shift the balancing point. The fact that it balances at the midpoint gives us a clue about where the rod own center of gravity lies. Our job is to use that clue to measure how far the rod weight center is from the thick ends. Now, after understanding and digesting all this stuff, now we can start solving the questions. Now, let's do it. Yes, we need to do the diagram of to present the whole scenario, but before doing the diagram, we need to know that unlike straight loads, which have got the constant diameter around its length, this one it doesn't have constant diameter because its thickness increase or decrease gradually from one end to another. Giving the conical shape. So now, we can draw the diagram since we know how tapered load looks like. So this is the thicker parts of the load, and this one here is the thinner parts of the rod. So the rod, according to the question, it has 160 centimeter length, and it balances horizontally. And horizontally when P when 150 gram hang at the end of the narrow part. So so the distance from the middle where it balances to the end of the narrow part is 8 centimeter, because we just have to take 160 divided by 2. Of course, we're going to get 8 centimeter. But the locations of the center of gravity is at the thickest part, because this is where now there is concentration of its mass. So we are going to lie here 200 gram, and the distance from the end, the thicker end to its center of gravity is x, but the distance from the center of gravity to the middle of the rod is 8 minus x centimeter. So now we need to apply the principle of moment, which says the sum of clockwise moment is equal to the sum of anti-clockwise moment. So what we are going to lie here, I'm going to lie here taking moment about P, which is our pivot, the point where the tapered loads are balanced. So after that, we need to decide between 200 gram and 150 gram, which one of these will cause clockwise direction and then clockwise direction of the road. So now I'm going to lie this way, and I'm going to lie this way. So that 150 will cause the body to rotate clockwise, while 200 gram will cause the body to rotate anti-clockwise. So it's just looking here, taking moment about P. So P will be our reference point. We are going to where all our distance is going to be referred to. So 150. 150 gram times this one. Before writing that, we have to write clockwise moment equal to anti-clockwise moment. So 150 times 8 equals 200 times 8 minus x. So if I'm going to multiply 150 times 8, what I'm going to get here is 12,000. And then here, 200 times 8, to open the brackets, what I'm going to have here is 16,000. So 16,000. Therefore 200x. So 200x is going to come to this side. So what I'm going to have on the left hand side is 200x, and then 16,000 minus 12,000. So from there, I'm going to left with 200 x on the left hand side, and then here, if we do correct here, we are going to have 4,000. Then divide both sides by 200. Divide both sides by 200. So I'm going to have left here with this one. Then I'm going to left with 20 centimeter. 20 centimeter. So our x here is 20 centimeter. What does the x represent? X represents the distance from the thicker end to the center of gravity of the tapered rod. So the question says, the question demands us to calculate the distance of center of gravity from the thicker end. Therefore, x is our distance. X is our distance. Therefore, I'm noting down here the distance of the center of gravity, the center of gravity from the thicker end is 20 centimeters. And this is you are supposed to do it.